So we're graphing sine x today, and we used the boundary values from this here, and then we wrote down a few of them, and then we plotted those points, and we drew the graph of sine x from 0 to 2 pi, just like it said here. And then we did cos. Wrote the boundary values down, we plotted them, and we drew this curvy sine. And now we're doing tan. Okay, here we go, tan. Okay, so on our calculators, let me get rid of that cursor. Did you type in y equals tan x? Did it go crazy? Are you in radians? Make sure you're in radians. Remember how to get there, mode, down here to radians, and hit it so it's blinking. And then second quit. And then I got y equals tan x, and I graphed it. Oh, I got a really bad window. It's nice, isn't it? It's wacky. Okay, I'm going to go to my window again. And I don't have anything over here. I'm just going to put -1 for my x min. And then I'm going to go over to 2 pi. Hey, I can go 2 pi on here. You want to see how? Ready? I'm going to go 2 pi. Because that's how far I want to go over, right? And then when I hit enter, it'll change it to a decimal. But that's okay. I know it's 2 pi. Now, really good. I want this scale. What's my scale? Every pi over 2, I'm hitting the grid, right? So my scale is going to be pi over 2. Now, what about the y min and the y max? I don't care. Whatever. -10 and 10 is fine with me. Scale, fine. Okay. Now I'm going to graph it. It's really weird because that's pi on 2, so that's like 3 on 2, and that's not really a great picture. Maybe I'll do -5 to 5. Maybe that'll be a little bit better. I think that's more what it looks like. Okay. Can you see the asymptote kind of right here? There's the asymptote at pi on 2. There's pi. There's 3 pi on 2. There's the asymptote. Okay? And if I go into the table, I can see that, okay. Can you go table set for me? Second window, table set. I want to start at 0, and what am I going up by? Pi on 2? Maybe I want to see what's happening in between here. So maybe I'll go up by like 0.1. I can see that here, this is getting really, really big, and then all of a sudden, there, it goes negative. So here's what's happening. This graph is going up like that, asymptotic to there, and then it's really negative. It's coming up from here. It's going like that. Really bad graphing referee, but it's okay. And then it's coming up. Okay, that's how it looks. It goes up, up, up. It's a wacky graph. Yeah.
Why does the undefined become an asymptote?
Because I can't have a point there. Right? Just like when I did the square root function and I couldn't have a negative underneath, and whatever made it negative, right, was like I couldn't go there. It became an asymptote. Or when I had a hyperbola like 1 over x plus 2, -2 became an asymptote because it made the bottom 0. Same thing. It's not the best graph in the world, but honestly, I think it's plus pi on 2. What's that? So that's 5 pi on 2. So this is going to kind of help me with all those weird, maybe exact values as well. 5 pi on 2 and 1. Okay, now I have 3 pi plus pi on 2. How do you write that? 6 pi on 2 instead of 3 plus pi on 2 is 7 pi on 2. Cool. Those are all the turning points. Identify the period and the amplitude of the graph. Okay. So let's write down what period is. period. We're going to have a formula for it, but for right now, it's how long it takes to repeat. So, if I start at 0 and I go like that, it starts repeating now, doesn't it? So this is one period of the sine. So there's 2 periods of the sine here. Is that all right? Okay, so the period of this one is 2 pi. That's how long it takes. The amplitude is however high or low it gets from the x-axis. So it can only go up 1 or down -1, so 1 is the amplitude. And it's kind of its max height. Okay? Its max height. And then here it says, give the equation of the equilibrium, that's the word we're going to use, position. Equilibrium. That's this, girls. It's where it's kind of oscillating about the x-axis. What is the equation of the x-axis? Y equals 0. Okay? So the equilibrium position is the thing that it's going around. Sometimes, eventually that's going to move up or down or whatever, okay? Identify the values for which f of x is less than 0. What do you reckon? What does less than 0 mean in a graph? What? So quiet. Okay, so it says greater than, sorry, not less than. F of x is greater than 0. So that's 0, is that right? So it's greater than 0 up here. That's where the y's are greater than 0, agreed? Okay, so how do I write that? So I write f of x between 0 and pi, and f of x between 2 pi and 3 pi. That's one way to write it. I guess I could have used the notation of 0 pi, 2 pi, 3 pi. That would be all right. Either of those notations are fine. Sorry. Yes. Oh, yeah, yes. Sorry. Good girl. Thank you. -3 pi on 2. That's -3 pi on 2. I'm sorry. To negative pi on 2. And then from pi on 2 to positive 3 pi on 2. Okay. Yep. The period? Okay, so I can start from here if I want. And I go, how long does it take me to get a whole curve in? All 4 parts. To there? So that's 2 pi. Yeah? The period's more like a length than a where you are thing. Like how far does it take? Yeah.